introduction. And next, we're excited to have Ximing Zhong to introduce his recent research on discussion on urban layouts workflow with generative AI. And Ximing Zhong is a Ph.D. candidate at Aalto University, where he has been awarded at a public doctoral scholarship. His master's school is Politecnico di Milano, Italy, and he's the recipient of the Global Gold Scholarship from Politecnico di Milano. His main research area are deep learning, architecture design, graph neural networks, and nerve, VN, and 3D reconstruction, human-machine fusion, architectural decision-making, reinforcement learning to meet architects' preference, environmental perception of complex spaces, and design institution machine learning. So let's welcome Ximing.
Thank you. Let me share my screen now. Can you see my screen now?
Yes.
Without the speaker note, right?
Right.
Okay. I'm Ximing Zhong, and it's my honor to be here to share my project. And I focus on human-machine collaboration for 3D spatial design. Please feel free to get to know me and connect me through the website above. And before we talk about machines, we can look at the design process of human architect. We human perceive the 3D environment. We understand and reason about the design element in our brain. We see from our eyes, and then based on this reason and knowledge, we make design decisions. Finally, we obtain a design prototype. What I want to explore today is how machine can work with humans to reason about a spatial layout. This can be summarized in 3 parts: perception, reasoning, and decision making in 3D world. Could machine replace human in this 3D in this 3D process? And since long ago, we have been exploring how machine can understand and design prototype just like human do. This is the shape syntax of machine. Human understand the design requirement and specify the rules. Then the machine searches for the rules, output the geometry drawing. We call this rule-based method. And this is an interesting case of Markov random fields and Gibbs sampling. The machine sample rules from one case study and generate new designs. Although this is also rule-based, but the idea of learning the rules from the case study and applying them to the new layout can already be called a pre-AI idea. And this is also a rule-based approach where humans and machines are involved in the process. We call this human in the loop. This is our paper, Human-Machine Cooperation for 3D Spatial Layout based on adjacency relationships. We made a plugin for Rhino. The task of the computer is to optimize the position of the modulars based on the adjacency and dimensional requirements of different spaces. And the architect's task is to modify the model to be more in line with the traditional modeling process. A human and machine work together to complete the layout. I always believe that the professional interaction process of the architect is valuable, so that the interaction process modifies the weight of the vector in the rule-based method, thus allowing the rules to evolve until the consistently meet the architect preference. In a rule-based driven process, rules can also be changed. And this is a result of our 3D layout. It's mainly access the space dimensions. This leads us to the limitation of the rule-based approach. We cannot turn all the design context and the complex implicit constraints into a rule function. So a machine cannot reason and understand as deeply as a human brain in rule-based method because the rules are too simplified. And a large number of data-driven approaches began to take over the field of architecture prototyping and generation. For example, GAN, the data-driven approach, does not require the definition of clear rules, but it can learn from the rules from the data set. The network of GAN is not new to anyone. The generators and discriminator work against each other until the generator can produce a data distribution that closely to the data set. We can take a quick look at the studies GAN has been widely used for urban design and layout. For example, road network layout, garden layout, house layout, and urban layout. By the way, this is a Tian's paper. We found two common points from those researches. The first, the way the architect controls the AI is through a pre-data labeling process. For example, in Tian's research, we can control the building layout by input different boundaries. And second, the good or bad result learned by GAN depended heavily on the dataset. Large datasets are difficult to obtain. Data labeling is also very difficult process. We ask two questions here. Does similarity means good design? Well, GAN models are adapted at quickly producing results that are similar to the historical urban symbols. It's difficult to meet architecture's future custom layout requirements by only producing results that are similar to historical symbols. So the similarity is not enough. And second, it's difficult for a machine to generate a low density result from a high density urban data site. Also, in order to generate results that meet our future design standard, we need a lot of manual selection rather than random sampling. The machine needs explicit dataset future labeling and data filtering to be able to control the GAN result well. And this is the training process of the GAN. GAN network is designed to generate similar data distributions, but the data relationships alone are missing message passing process in this network. This is a GAN fitting process. We can find the gradient of each point. We find that the generator function can turn a random simple distribution into a distribution similar to the dataset. In the GAN network, we have many functions, gradient functions, as you can see in the picture. But does this function represent a well-designed rule, like rule-based method for good design? And we can see the GAN can quickly turn a random noise into a ring shape using a generator. The distribution of this ring is similar to the real data. But when we look closely at the points on the ring, we have no way to explain the relationship between each point. We cannot relate too much on the distribution of these implicit features. It is necessary to be defined some explicit features to allow the machine to understand the architecture design intentions, and the way the data is labeled determines the way architect and the AI work together in GAN network. This is why data labeling and data filtering are so important. And how to design a specific sampling and automatic feature extraction framework that helps architecture to explicit control the hierarchical urban layout features and meet complex urban design needs is our concern. As an architect, we need to control what to study and how to study. This is quite abstract. Let's take an example. So we ask the GAN machine to generate a design competition proposal for the Milan. We can look at this brief. We need a high density functional rich, low heat, more green area, residential and mixed use the urban design. And the government's brief also summarizes some requirements for specific morphological features of the city, such as open boundaries, open occupation boundaries, and something. We make an assumption if we can automatically filter the city data by the design requirements, and the features of the city are automatically extracted for data targeting, then we can better control the urban layout. Architect can work better with the GAN. This is our process. We need to do the first step is case filtering, and then extracting morphological features and targeting, and we can get a 3D prototype of urban design when architect enters new control element and relationships. This is my third. Step one, we download the urban data from OSM and automatically filtering the data. For example, we can filter out low density urban forms from OSM. And then we can automatically analyze and extract urban morphological features and target the data. And then we train GAN model. And fourth, we want to architect to be able to use these layers hierarchical urban morphological features to control the generated 3D result. And this is a simple of 4,000 cases were selected that meet the standard of function density and functional diversity and the heat. The choice of morphological features, Roy has used the feature map to teach his students how to complete the analysis of the cities and urban design in the past. And nowadays, maybe this process can be done by machine learning. So we choose these morphological features from the Colin Roy's idea. And an example on the left side is urban feature map. It has design marks for the boundaries, open spaces, openings, road networks, something like that. And on the right side is a map of the real city. The map on the left, we can understand as a maker for human understanding and reasoning about urban design. And let's see urban features definition from the book Learning from Las Vegas. And boundaries, road network intersections, openings in the boundaries, open space and building relationship. So inspired by the feature map, we have formed our feature network, hierarchical network to control the morphological layout. We believe that these important features should be analyzed and extracted. And we hope that the GAN can learn the hierarchical relationship between these features. We have automatically marked and learned about urban features. We have compressed the feature in the blue channel and the heat in the green channel. So the 3D volume and the functional distribution of the city can also be learned automatically. And this is the input and output screen. We input the node of the space and to get the layout of the road and open spaces. And we can generate a 3D layout by modifying the road network and set features. We can see that with the layers features, the architect can better control the urban layout, meeting the metrics of the computations mission statement. GAN does not learn the implicit features of the building distribution or data distribution. It also learns the explicit hierarchical morphology features. And we can control these features. And in the result section, first, we verify the functional diversity and the density. The result produced by the machine meet the requirements of our task from the beginning. And then the machine production 3D volume and function distribution. Again, we made it a Rhino plugin. Architects can work with AI to create a special layout in the same way that they draw the CD, and again can design the shape and the function of the building. Then we refine the modulars and landscapes. By the way, thanks to the 3D detailed model generation, we can use machine learning of the wind environment for landscape design. It's another paper we did 2 years ago. And this is final layout and urban design guided by the architect with features input and standards input, and machine finish the layout process. And some limitations. Have you ever wondered why would not apply GAN to generate new drugs for experimentation? Would you dare to take a new drug if it was a GAN machine learning generation? This is because the explanation of the GAN model is very poor. And GAN's convolutional model, you can recognize any graphic. But why it is so difficult to truly understand a human reasoning task such as a Sudoku or chess or something like that? Human reasoning task. So this is a question about my previous paper, I think. How do we ensure that the machine actually understand the design message we input in 3D space and it can reason and perform reasoning tasks like Sudoku in 3D space rather than just providing a similarity data distribution? let's take a brief look at a GAN graph neural network. A GAN is made up of nodes and edge. Many of the studies around us can be modeled using GAN networks. For example, the cities, human relationships in real world. And we know how messages are passed between each node and the result of the calculations. It is also possible to know better the details inside the black box. And in the layout application building GAN, it's the same author with the host GAN in Tian's presentation. And the architect can enter a complete diagram structure of the design requirement, which can be combined with GAN and GAN to produce a 3D voxel model. But there are still some problems with this approach. The first, when the architect needs to reason and input the complete spatial structure, by the time I already know the structure of the space in my head, the design has almost been reasoned out. The task has almost finished. And second, the control capability is not processed to each unit space size. Inspired by this, the question is, can machine intelligence and human intelligence be connected through a faster network to explore new prototypes together? We know human and machine have their own advantages. Can GAN, this network, be our partner in solving the challenges of 3D building shape exploration and spatial segmentation? And this is building GAN is our new project of ours, accepted by IDD this year. For now, sorry, I can only show some part of this result and ideas here. The architect can input incomplete volumes and partial ideas, including constraints and set context. These volumes are then transformed into a matrix of spatial nodes, and the GAN is able to reason about detailed spatial design solutions. And why is important? The architect can engage the feedback loops with AI to jointly explore and optimize design solutions. Not only AI is used to speed up the design process, but the architect's perception and understanding of the site is also be used to assist AI in interactively exploring the 3D building layout results. And this is a challenge. In the past, in the previous study, it's a big challenge. If you want to solve the complex constraint and long-term dependency problem for highly accurate and reason networks, only GAN are not enough. For example, how can a machine learn relationship between room A and B if there's no obvious graph relationship between these two nodes? The A is a toilet, the B is the classroom. And when in architecture design, when I change the A position and A size, the information will be passed to B in our brain. But for computer, if you do not make a link, directly graph link, there's no message passing network or message passing ways for machines to understand what happened inside the two graph. So we combine the spatial graph networks and memory networks. Here we use GRU, and building GAN network is created for reasoning the unit relationship in 3D network. So here are some simple examples to show. On the right are some of our idea inputs, some volume. On the left is a complete reasoning result by GAN network. And we can see that GAN network has a mind of its own. It will change the human design to meet functional and traffic requirements. It's not like the rule-based method. We set some rules. With these rules, the machine will follow this rule step by step and generate the geometry. But in GAN network, it will change the wrong things in latent space, and it will change the humans started volume input. We experiment with the model on different buildings. GAN itself can reason it has some reasoning intelligence, and this intelligence can be controlled quantitatively with our GRU module. With RN, we can choose how much the machine intelligence and human intelligence to use to combine together. If you need more detail and information, please follow the ICADI conference this year. It's not published yet, so I can just show you part of this idea. And that's all. Thank you.
Okay, thanks, Ximing. And now we come to the Q&A section. Do you have any questions for Ximing?
Hello.
Hi.
Can you hear me? Yeah.
Yeah. Please.
I just have a comment. Firstly, the theme. You spend too much time on introduction, and you introduce a lot of related works. I think a better academic presentation should focus on your own contribution. That's the first comment. The second comment is that I think your pronunciation has a lot of problems. For example, you read data. I remember you read it that as data. So yeah, there are a lot of things I think you need to improve if you want to be a better want to have a better academic career. So currently that's my comments. Thank you.
Okay, so I finished work.
Okay, if we don't have like further questions, we can say if we have other questions, please feel free to join our WeChat group for following up. Or if you're watching the live streaming on YouTube or Bilibili platform, please feel free to contact the author Ximing Zhong or Runjia via their email. And we are highly encourage any young designers and scholars to share your work and projects and current research on our platform, and you can see all the information on our website. And thank you again for joining Innovations in Digital Design webinar, and thank you all.